Moba is a modern, innovative company with about 70 employees. Together with the subsidiaries in Dresden and Italy, Moba is a company offering high-performance mobile control, measuring and logistic systems. The main activity of the company is directed to the following areas: machinery controls, weighing systems, ident systems, system software. A competent customer advisor service has resulted in the development of intelligent products which are ideally suited to the market. This leads to a considerable increase in efficiency of the end product. Worldwide representation ensures optimal local support of our customers. In 1994, a revolutionary system for the leveling of the screed was developed, the Moba Matic. Due to its accuracy and its simple operation, the system became a great success within 1 year. 4 different types of sensors are available for equipping the road paver. The Digi-Slope sensor for slope control. The Digi-Slope sensor is equipped with an LSTA sensor unit, especially developed for the road paver. It enables slope control for even very wide screeds and was conceived in addition for high compaction screeds. Because of its reliability, the LSTA sensor unit has been used for the last 20 years in the well-known S276A slope controller, a proven technique. The sonic ski sensor. For all applications, the sonic ski sensor employs contactless, ultrasonic techniques. The use of 6 ultrasonic sensors enables a sensing range of 25 centimeters above the string line. For ground sensing, the sonic ski calculates an average value and can therefore smooth out irregularities of curbs or gutters. The Digi-Rotary sensor for grade control. If the use of an ultrasonic sensor is not possible, the Digi-Rotary sensor is a good value for money alternative. The Digi-Rotary sensor works with the same principle as the proven grade controller G176B. As accessories, a sensing arm, a sensing tube, and a sensing ski are all supplied with the Digi-Rotary sensor. The LT360 laser receiver for grade sensing. The LT360 is used everywhere where a rotating laser transmitter is employed as a reference. Laser transmitters are preferred for the constructions of airports and car parks. The digital controller recognizes the sensor which is connected and is immediately ready for operation. The operation of the various sensors differs only very slightly and causes no problem to the user. The Moba Matic. For every application, the right sensor. The standard system is installed on the paver in a few easy steps. The digital controller is fitted into the standard holder. The cable of the digital controller is plugged into the machine connector. The Digi-Slope sensor is fitted into the standard holder and connected to the digital controller with a spiraled cable. To fit the sonic ski, the same procedure is followed. First, the controller is fitted into the holder. Now, as with the Digi-Slope sensor, the cable of the digital controller is connected into the machine connector. The ski is fitted into the standard holder and connected to the controller. Finished. If the sensor has been fitted for the first time, or if a sensor has been changed, the new sensor must be acknowledged by pressing any one of the keys. With the up or down key of the controller, the toe point is brought to the start position. To set the set point to be the same as the existing actual value, press the return key. The display shows the actual value again. By pressing the AM, or automatic manual key, the automatic control mechanism is activated. The controller now controls to the set point displayed. During operation, the set point can be changed by pressing the up or down keys. The controller immediately controls the actual value to the new set point. If the sensor has been fitted for the first time, or if a sensor has been changed, the new sensor must be acknowledged by pressing any one of the keys. By simultaneously pressing both the up and down keys, the string line mode can be activated or deactivated. This example shows sensing of a string line. The illuminated string line lamp is a confirmation of the selection made. The toe points can be set to the start position by pressing the up or down keys of the controller. For stringline sensing, the ski must be positioned at a height of about 350 mm crosswise above the string line. This is signified when the actual value display no longer flashes. By pressing the return key after positioning the sonic ski, the actual value and set point are set to 0. After pressing the AM key, the controller works automatically. The set distance between the sonic ski and the sensed reference is kept constant. During operation, the set point can be changed to the required value by pressing the up or down keys. The sonic ski immediately controls to the new distance set.
Die Moba Matic ist leicht anzubringen, wir sind damit voll zufrieden.
What should the ideal ultrasonic sensor look like? It should allow working above the string line without any problems. Practice has shown that a sensing width of 25 centimeters above the string line is sufficient. In addition, 5 sensors are needed to calculate an average value and to control accurately with the string line. Temperature variation should be compensated for by measuring the ultrasonic speed with a 6th sensor. Now it only needs to fit into the standard holder and work together with a digital controller. Add a nice color, and finished. Now that's what an ideal sensor should look like. How is distance actually measured with ultrasonics? It's simple. You need a sensor that can send and receive ultrasonic waves, a reference surface, and a stopwatch. The sensor sends the sonic waves in the direction of the reference surface and starts the stopwatch. The sensor is then switched over to receive. The sonic waves reflected back cause the stopwatch to stop when they are received. Once again in slow motion. The sensor transmits sonic waves, and at the same time the clock is started. The sensor switches over to receive. The sonic waves are reflected, received by the sensor, and stop the clock. Because the speed of sonic waves is known, the time measured can be used to determine the distance between the sensor and the reference surface. But unfortunately, it's not quite that simple. Sonic waves do not always travel the same speed. Their speed is dependent on air temperature. Sonic waves travel faster in warm air than in cold air. By making a reference measurement in which the distance is known, a sonic speed reference can be established. Here, it must be noted that the reference measurement determines the air temperature of its own reference distance, not the temperatures outside this range. Then, greater the distance measured, the larger the measuring error is. For a distance twice as long, the measuring error will be twice as large. And concerning errors, what happens if, When stringline sensing, the ultrasonic sensor does not detect the stringline, or when ground sensing, large stones hinder measuring. To eliminate such errors, Moba has integrated a control window for the sonic ski which, as standard, is set to plus or minus 3 centimeters. This value can of course be altered according to circumstances. The control window works as follows. Obstructions which are larger than the control window are ignored, and the controller stores the last value. If the control window has been set too small, there may be complications with large changes of reference, for example on steep slopes. The control window itself is not designed to compensate for irregularities of the reference. This is done automatically by the sonic ski taking an average value. Systems that work with only one ultrasonic sensor light up an area of about 25 centimeters. The reflected sonic waves first detected are taken as a true measurement of the distance. Unevenness of the reference is simply copied without correction. For ground sensing, the sonic ski works with 3 ultrasonic sensors. From the resulting 3 independent measurements, an average value is constantly taken. In this way, irregularities in the course of the curb or the gutter are compensated for. Not quite. When detecting with a magnifying glass, one can detect small errors, but the ski is still 3 times more efficient than a single sensor. Ultrasonic waves spread out in the same way as a cone of light. Sensors which work with only one ultrasonic sensor must be positioned about 60 centimeters from the string line. Only then, and very inaccurately, can a sensing width of 25 centimeters be achieved. It's not always possible for the driver of the paver to keep the 1-unit sensor directly over the string line. A 25 centimeter sensing width can result in a possible deviation of 12.5 centimeters. And, for a deviation of only 12.5 centimeters from the vertical, there is a measuring error, according to Pythagoras, of more than 1 centimeter. Therefore, the sonic ski from Moba is fitted with 5 sensors. For stringline sensing, only one sensor is evaluated, the one with the shortest distance to the string line. Thus, an accuracy of plus or minus 2 millimeters can be achieved. It's not a trick, it's a sonic.